Good morning, friends. All are there?
Good morning, sir.
Okay, fine. So, in continuation with the yesterday's session, we will see a few more in detail the program related to that LEDs, and plus we will go ahead for the unit number 4. So, I hope till the unit number 3, the instruction set, the pinout diagram, what is interfacing, and how we can do the interfacing with various peripherals, external peripherals with 8051. So small at least peripherals we have seen, that is the devices, how we can connect. So you supposed to read it once, revise it once, that is the how the hardware has to connect and what program we have to write or we have to burn into 8051 to work it. So these are the main tasks onwards, whatever we are going to learn in next unit also. Because the next unit is also dedicated for the interfacing only. So in that various external peripherals we are going to connect or interface with 8051, and related to that we will have a talk in the later in this session. Now we will start with that yesterday's practice, that is what the we have modified, we have edited the program related to the LEDs simulation. So today also we will start with the one of the activity or the one of the modification in the same program, and it is a little complicated. Definitely it is not as much easy as that of the yesterday whatever we have seen. But if you got the logic yesterday, that is how to do, what to do, where to do, so definitely you can at least try for this type of the program. So now what I want today is that, just I will open that the XLS so that it will be easier to tell you. 1 2 3 4 5 6 7 and 8. So these are the 8 LEDs, suppose for P1 port. Now what I want is that when the program will start, the LED will start glowing this one. After a delay, this LED will shift to its right position. That is, the next position will look like this. Here one. And all others 0 definitely. After a delay, this LED should go to the this one, and all others will be in off condition. So it will be rotating the hint what I am giving. So it will moves to the right. So 1 2 3 4 5 6 7 8, like this it is going to be rotate, and again it will start from the MSB bit. So like this I want to flash the only one LED at a time. So for that, what type of change we supposed to do in the program, that I want from you today. So at least have you got the question? That is, I want to just shift the LED glowing to the right. Only one LED at a time. So what change we can do in the yesterday's program? At least try to put your logic, try to write the program for that, and if few lines has to be added, so just put in the chat box. Definitely in the notebook first you note down all the program, and then where the changes are there, that only you can put in the chat box. Take your time, think on that, and give the solution to me. Yesterday's program is with you, so I'm not going to show that once again. So just making here that what exactly it is expected. So in this manner, we're supposed to show that LED flashing. So how we can write the program for this? Many logics are there, but with minimum number of the instruction that we have to manage. So for that, all the instruction set or the all the instructions we should remember or we should know, so that which instruction can be applicable over here, and all the 10-15 lines can be converted into the only one or two lines. That can be possible. So try to make that. Okay, one answer I got in the chat box. But suggestion that is 50% correct. So just check out the syntax for that. Okay, immediately she has done that. Now 90% it is correct. Only a little logic here it goes to be changed. So this is the one way of implementing the same. Very good. But the other logics can anyone has with them, and expecting from the boys side also participation in such programming skills. They are just sitting idle and just watching that what is going on. But take the participation in this and try to put your logic here. So she has tried with the instruction RR. So everyone should know at least that what is this RR. So no one else want to share the answer. So one can think is that ki if for first stage this is 1 and all others 0, means it is equivalent to 80H. Then second bit or the LED will be 1 and all others 0. That means it is equivalent to 40H. Is it? Because if you are writing all other places 0, so 0 1 0 0, that means 4, and this zeros means 0, like that. So here it will become 2 0, it will become 1 0, here it will become 0 8, here it will be 0 4. That 0 it is skipping, so 0 2, and here it is 1. Like this, the rotation or the input has to go to the port 1. So that is the one logic. First add 80 or move P1 comma hash 80H. After a delay 40H. After that 20H. After that 10, 8, 4, 2, 1. So that will give the this result. But for that it will take so many instructions and it will consume the number of bytes. So the another solution is that whatever the this Aboli has put over here, use the only one command that is called RR. But this RR command is normally it has been applicable for the accumulator. It works on the accumulator. So accumulator we have to take here in between our port and the output. So for that, I hope no one is want to participate over here. So the program it is I will ready and I will just paste over here. So this is the simple program is there. Just try to read this program, what it is written. Only 3-4 line program is there, nothing else. And this part it is of delay, and what delay you can write, how to write, or the fixed lines, that also I given in the last session. So this is delay, that no directly it is a connection with the our program. So main program is the above one, this much only. This is the main program by which this rotation can be happen. So those who want to write, you can just note it down this. What heading you can give for this? Shifting of LED to the right. And the condition is that only one LED at a time. So for that, this program can be written. So what it has been done here, so you can just check it out, because as I told that key here we have to take the accumulator in between. So whatever the data it is ATH she has told, so that data we have to move first to the accumulator, then it has to shift to P1, not directly the AT to the P1. Why? Because here RR we have to apply to the A and not P1, because few commands are here which are only working on the accumulator. So that also one few restrictions are there in this 8051. So that also we supposed to consider over here. So this is the program for that. So everyone can copy that this program. Only program it is sufficient to write. For delay, it is not needed to write this much. End is important. No? So don't forget that. That end is not a part of a delay. So that end, it is a part of a main program. So if you have copied this program, so let us just check that whether it is giving the output as per our expectation. No errors in this. Start debug. Click on OK. So which port we have taken? P1. So I will just peripheral IO port 1, and I will run the program now. And you can check it randomly as it is moving fastly because that of the delay, but last bit, then one by one it is just rotating to the right. So this is how we can do by just making a addition of a single this instruction RR. So this is, can be possible. Got it? Okay. This delay we will talk afterwards. So whatever you want, you can just add into this delay, and for delay we are going to talk after few time. So forget about the delay. Next, now the task in the same way, rotating to right, I want rotating to the left. So what change we supposed to do in this program? That I want now. And expecting the answer from the others, not from the aboli. Now I want that the LED should run to the left. So what change we supposed to do in this program or code? This is assembly code, low language code. The same program you can write in the C language also, that is embedded C, but we are not concentrating on that. The interfacing can be done, or the coding can be written in two ways. That is, one is this one assembly code and the other one is the embedded C code. So this embedded, this low level code, that is much easier than that of the embedded C. So that's why we are preferring here that this one. So only the hint I got from that one more student, but exactly what command we supposed to write there, always whenever you are giving the answer, so in that way you supposed to provide the answer. Okay, so she has written that replace RRA by RLA. Okay, so what the others are thinking, is it correct? Just replacing that sentence or that line, can we achieve our expectation output, or something somewhere else also we supposed to do the change? Can anyone? Okay, now after the giving a little hint, so now I got the correct answer from your side. So first answer was also correct, not correct, that was not the matter. But what we are trying to design is that the led at position lsb will be flash first, like that. That is our mentality, or that the what the process we want, that is the led should rotate to the left. So that's why the 0 1 now we have taken. But with that 80 also, it is possible to rotate to the left because it is in a circular manner. So with both we will just check out that the which is more correct or which is look good. So first we will keep as it is the 80h, and as per her replacement we will just replace it by RL. And now we will check out whether it is giving any error. No error. And check out the output now carefully. And I am now running the program. So what you are observing? So besides that, you can check out that the it's a decimal. What we can say that the conversion 2, 8, 40, 80, 1. So in that way, it just goes on shifting. But as the delay is very less, so we cannot just identify that ki अरे कुठून कुठपर्यंत चाललंय कसं चाललंय. But it is seen there, that is it is rotating to the left. 7व्या बीट पासून जरी चालू झालं तरी पुन्हा 0 वर येणार 1 2 3 4, परत 7 वर, परत 0, परत 1 2 3 4 up to 7, like that. So this is also the correct solution for that the respective. Now we will do that next modification. That is what it after the hint it was given. So in A we're supposed to move hash 01, hash 01, not 001, but it should be 01. And all other part is it is the same. Now again save. Let us check that any error there. Debug mode I have gone through. Okay, not yet. So we have to come out from the debug mode always. if you want to edit the program. Just remember, because right now you are just looking here and you're not practicing, but when you are coming here and doing the practice, so that time that is to be remember. Zero error, debug mode on, and uh, port 1, and I will run the program. And now check out carefully the output. Right now it is FF, and here again the same type of the output we can observe to our eyes due to that fast delay. The same thing it is going to be happen, that is it is rotating to the left, but it is starting from the 0th position. That is what we have written in the accumulator, that is 0 1. Got it? So both answers are correct. So from only the depending on the position from where to where you want to just get it shift, so accordingly you supposed to make that changes. Got it, this one? So if you want, just note it down, take 1-2 minutes and note down this program. This is the main program. This is the delay that we are going to talk now. What exactly the delay is and how we can decide the how much delay we can insert. 1 millisecond, 1 microsecond, 1 second, like that. एवढा जर डिले हवा असेल तर कसा प्रोग्राम लिहायचा त्या डिलेचा, काय ह्याचा मीनिंग आहे. So that we will have a talk. Right now you just copy it, this program with RLA. So this is what the end we are going to do for small programming related to LED. So what the title you can give for this program? Rotate the LED to the left with condition only one LED at a time. Is it written? So that we will move ahead. This delay program I am replacing with this code. So what is this code and what is this that we are going to discuss over here. Just now focus on this delay program, and this is the delay exactly after the modification and rectification. So whatever the lines I was given to you before, so instead of that you can remember this. So give the heading, write a program to insert I hope all are with the pen and paper. Don't run right now. Write a program to generate or create a delay of 1 millisecond. 1 millisecond. तर त्याच्यासाठी प्रोग्राम कसा असेल? So just whatever I have highlighted, you now copy it. Then I will explain. The answer for that generation of delay of 1 millisecond. So this is the answer. So write down. So what the program it is? डिले ते सुरुवातीला कशासाठी लिहिलेलं आहे? तर आपला हा जो मेन प्रोग्राम आहे त्यात आपण डिले कॉल केलेला आहे. तर त्याचं लिंकिंग इथं व्हावं म्हणून तिथं जे स्पेलिंग आहे तेच स्पेलिंग स्मॉल कॅपिटल इट शुड मॅच. सो दॅट इज रिटन. अँड व्हॉट इज डन आफ्टर दॅट? मूव 2 रजिस्टर्स घेतलेले आहेत. R6, #250D. D stands for decimal. And the same for R7. Move R7, #250D. 250 का घेतलं? So that is very important in this case. 2 रजिस्टर घेतलेले, दोन्ही रजिस्टरला व्हॅल्यू इनपुट दिलेले आहे 250 डेसिमल. 250 आणि त्याच्या पुढे काय केलेलं आहे? तर 2 लूप तयार केलेले आहेत. लूप म्हणजे काय? लेबल 1 DJNZ R6 म्हणजे जर ह्याची R6 ची व्हॅल्यू नॉन झिरो झाली तर कुठं जा? लेबल 1. लेबल 1 म्हणजे इथंच. म्हणजे हा एक लूप तयार होतोय 250 वेळा. तिथंच ते गोल 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 फिरणार. ते 250 टायमिंग संपल्यानंतर पुन्हा DJNZ R7 म्हणजे जोपर्यंत R7 झिरो होत नाहीये, डिक्रीमेंट अँड जम्प इफ नो झिरो. करेक्ट. डिक्रीमेंट अँड जम्प इफ नो झिरो. जोपर्यंत R7 ची व्हॅल्यू एक एक न कमी करताना झिरो होत नाहीये तोपर्यंत कुठं जा? लेबल 2. लेबल 2 म्हणजे इटसेल्फ हिअर. म्हणजे इथं सुद्धा एक लूप तयार झालेला आहे आणि तो किती वेळा रन होणार आता? तर 250 वेळा रन होणार. दॅट इज व्हॉट इन दिस जनरेशन ऑफ डिले टोटल किती वेळा हा लूप रन होणार? 250 प्लस 250 500 वेळा रन होणार. करेक्ट. दिस इज व्हॉट लॉजिक आय वॉन्ट टू टेल दॅट की 1 मिलीसेकंद डिले कसा तयार होतो. तर 500 वेळा हा लूप रन होणार. परंतु एका DJNZ इन्स्ट्रक्शनला टाइम लागतो तो 2 मायक्रोसेकंद. Because DJNZ is an instruction which requires the 2 machine cycle, or it will occupy the 2 bytes in the memory. आपण ज्या सगळ्या इन्स्ट्रक्शन्स लिहून घेतल्या होत्या त्याच्यात लिहिलेलं आहे बघा की प्रत्येक इन्स्ट्रक्शनला किती बाईट लागतात. काही काही इन्स्ट्रक्शन 1 बाईटची आहे, काही काही इन्स्ट्रक्शन 2 बाईटचे आहेत. तर तसं DJNZ will require the 2 machine cycles. म्हणजेच इट विल रिक्वायर 2 मायक्रोसेकंड टाइम. आता तुम्ही म्हणताल की मग 2 मायक्रोसेकंड कसं कॅल्क्युलेट केलं? सो सी हिअर केअरफुली. आपण जो 8051 आहे त्याची फ्रिक्वेन्सी आपण नॉर्मली पकडतो 12 मेगाहर्ट्झ. बरोबर. म्हणजेच 12 मेगाहर्ट्स ही फ्रिक्वेन्सी आहे, म्हणजे 12 सायकलची 12 मेगाहर्ट्स. तर एका सायकलची फ्रिक्वेन्सी किती असणार आहे? 1 megahertz. And that is what time required for one machine cycle, that is 1 microsecond. एका सायकलला लागणारा टाइम आहे 1 मायक्रोसेकंद. परंतु आपली जी ही कमांड आहे डीजे एनझेड, सो इट इज रिक्वायर्ड द 2 machine cycle. 2 machine cycle means 2 microsecond. It will take time for 1 instruction. म्हणजे एकदा ही इन्स्ट्रक्शन रन करायसाठी 2 मायक्रोसेकंद हा टाइम लागणार आहे. आणि आपण आत्ताच प्रोग्राम मध्ये बघितलं तर 250 आणि 250 असं टोटल 500 वेळा ही इन्स्ट्रक्शन रन होणार आहे. म्हणजेच 500 into 2 मायक्रोसेकंद, and that is nothing but 1000 microsecond, and that is nothing but 1 millisecond. असं हे कॅल्क्युलेशन आहे ह्या डिले प्रोग्रामचं. So if you want to write, you just note it down in your words ki how this step by step it has been explained, and this goes to the generation of delay of 1 millisecond. So it is in front of you, just I will put as it is the for 1 minute. You can note it down in your words, and then we will go to the program. Note it down. Okay, so this is how this is the modified correct delay program for 1 millisecond, and always the same code you can insert in any of program. So you just make it that the final coding for delay, because you can observe on the internet or in the book also that is at many places different delay logics are written. कोणीकडनं तरी डिले इन्सर्ट करायचा आहे, तर मग कसाही तो करू शकतो. बट इफ लॉजिकली इफ यू आर थिंकिंग की 1 मिलीसेकंदचा आपण डिले इन्सर्ट करत आहेत, तर हा कोड तिथं तुम्ही पेस्ट करू शकता त्या कोडच्या ऐवजी. Because sometimes they have written the delay for 1 second, 2 second. So this code is going to be changed, but this is the standard. We can decide that okay, this is the code for the 1 millisecond is there. And simple what we can say that the hint की तुम्हाला 2 मिलीसेकंद डिले जनरेट करायचा आहे. Listen carefully. If you want to generate the 2 millisecond delay, so the simple idea is just what I am doing. See in this here, whatever the command it has been written. So just call it two times. Simple way. That is 1 millisecond and 1 millisecond. So it becomes the 2 millisecond. So this is the simple way, shortcut way to make it. Otherwise, if I will ask for the 1 second, so that time don't just repeat a call delay, a call delay, a call delay, a call delay these many times so that it becomes the 1 second. But for that, different logic has to be used or the modification has to do in this code. But right now, you just note down that this is the program for the generation of delay of 1 millisecond. I hope all of you understand that what is this meaning and how this 1 millisecond it is generated. Now let us see with this code how that the program output is look like. 1 millisecond म्हणजे किती लहान टाइम असतो, so that you can check it out over here. I am running the program. See, yes, we can observe by our eyes that this is going to be shift. Actually 2 millisecond that delay we have given. So like this you can modify this particular the code which can be run. So I hope all of you got that the concept of this delay also what today we have studied. Now we will go out of this and so this is also, I hope you understand that how this particular frequency is divided. That is the crystal frequency. This is 12 megahertz and one cycle means 1 megahertz. That is time 1 microsecond. But as the DJNZ takes the 2 microseconds, so 500 into 2 that becomes the 1000 microsecond. That is nothing but 1 millisecond. So this is also we have done. Now the few questions to yours. See the slide in front of you and try to identify that is this code is written for what, because already we have studied this, but only I have kept the code in front of you so that I want to know from your side that are you able to identify this particular the reason of this particular writing the code. So just put in the chat box that if you are able to identify that this code is for what purpose. So don't go to the back pages and where you have written the code and all that, but from this only you supposed to आयडेंटिफाय की अरे हा प्रोग्राम आपण ह्याच्यासाठी लिहिला होता किंवा ह्याच्यातनं काय आउटपुट आपल्याला मिळणार आहे. Okay, Vaishnavi also given the answer this time. Very good. So this answer it is having the this one, that is the correct LED blinking. That is the one LED only we have connected, and how to make it on off on off. So for that this code it is written. So that one LED it is connected to which port or which pin instead of port, which pin? So that is P2.0. P2.0. So first it is off, after a delay it is on, again call delay, and jump to loop, that is again off. So that is what the program it is written for LED blinking. Very good. Then go to the next. And this delay program. So now this delay program, and everywhere you can see the different delay program. But just now whatever we have seen for 1 millisecond, so that you can keep as a final delay program. So everywhere you can replace it by that. Now this code. For what purpose it is here. Okay, is it buzzer? Is it buzzer? So with this turning, all are getting in now in confusion, but this is the correct answer, and this is what the diagram we have seen for that. The buzzer it is connected to port 1.5 and it is operated by the switch at 2.3, that is port 2 and 3 number pin. So this is what the 2.3 here. Keep monitoring for high. When this signal becomes 1, so that time P1.5 will become high and that buzzer will start sounding. So this is what the code. So it is buzzer coding. Good, madam. Next. So this is the slide which is needed from your side now. So you are in a third year, first semester, and you are studying the microcontroller and its applications or the interfacing with the other peripherals. So with that, it is expected this is the prerequisite for unit number 4. So you should know that what is relay, what are its types, how it works. Because the unit 4, it contains the interfacing of these all with 8051. So how to interface that I can teach here, but what is its main function or how it works, at least that you have to know. त्याचं फंक्शनच जर माहित नाही तर नुसतं इंटरफेसिंग करून ते कसं वर्क होणार आहे किंवा काय इनपुट दिल्यावर काय आउटपुट मिळणार आहे हे काहीच नाही कळणार. So just note it down this in your notebook that today you have to work on these all 5 points. की रिले म्हणजे काय असतो, रिलेचे टाइप्स काय असतात आणि ते वर्क कसं होतं हे जर माहित असेल तर इंटरफेसिंग कसं करायचं 8051 शी, that you can understand. because it requires the circuit diagram plus software code. Both it is required. पण जर तुम्हाला रिले काय आहे आणि तो वर्क कसा होतो हेच जर माहित नसेल तर you cannot judge that what is this program it is written and what is this interfacing. In the same way, stepper motor. मोटरचे बरेचसे टाइप्स आहेत, डीसी, एसी. मग इफ I don't think that this all you have studied in any of the subject. If you have studied, then it's a very good. Shubham Ausekar, are you there? Shubham. So have you studied this in any of the subject?
रिले स्टडी केला रिले. रिले.
Shubham, don't mute your mic. Just keep it on. Shubham Ausekar. So what is the question? काहीच ऐकायला येत नाही बाळा.
5 पॉइंट मधलं कुठलं स्टडी केलाय तू सर?
सो त्याच्यातलं काय काय तुला माहित आहे?
रिले ऐकलं.
Okay, that means at least some knowledge you are having. So now today's task for you all. Now you can mute yourself. So today's task is that like that the relay, what is stepper motor, त्याचं construction कसं असतं, कसं वर्क होतं. So that also you supposed to search on the Google. Plus third one, that is the LCD display. आपण मॅट्रिक्स बघितला एलईडीचा की कसं डिस्प्ले वगैरे करायचं, परंतु एलसीडी डिस्प्ले दॅट इज हॅव्हिंग द 16:2 साईज, म्हणजे 2 रोज असतात आणि 16 LCDs असतात. एलईडी सारखंच आहे, एलसीडी म्हणजे काय असं वेगळं नाही, बट इट इज अ कॉम्बिनेशन ऑफ 16:2 म्हणजे 32 कॅरेक्टर्स वी कॅन डिस्प्ले ॲट अ टाइम. मग त्याच्याशी कसं कनेक्शन करायचं, त्याचं कुठलं मॉडेल मार्केटमध्ये अवेलेबल आहे, त्याची पिनआउट कशी आहे, सो दॅट यू सपोज टू स्टडी. ते जर असेल तुमच्यापाशी तर इंटरफेसिंग वी कॅन स्टडी. आफ्टर दॅट एडीसी अँड डीएसी हे काय कन्सेप्ट आहेत, कशासाठी लागतात, कुठे लागतात आणि त्यात कन्व्हर्जन कसं होतं, म्हणजे अॅनालॉग टू डिजिटल आणि डिजिटल टू अॅनालॉग. सो दॅट इज एक्सपेक्टेड फर्स्ट दॅट की द स्टुडंट शुड नो बिफोर गोइंग फॉर द युनिट नंबर 4. Got it? So this is the prerequisite for unit number 4. Otherwise we cannot start the unit number 4. So just hoping that in today's or at least 1 to 3 somewhere basic knowledge you just take it off all these 5 points. So this is what today's session. I want to stop over here and stop sharing, and you can put your attendance, and don't forget to write your name, number in the chat box. From that only I am just putting the attendance, so afterwards there should not be any miscommunication. Don't forget to write. And if you are not able to put in this chat box, so you can personally just put the attendance to my number.